All right, hello once again. This is Jeff Scott of Rankin Technical College. I've been going over the online PDF textbook, AppInventor2, Create Your Own Android Apps by David Wolber, Hal Abelson, Ellen Spurtis, and Liz Looney. And I'm up to chapter 16, which is Programming Your App's Memory. This chapter, as it mentions, examines how you can program an app to remember information. Just like a human being, an app has memory as well, but its inner workings are far less mysterious than those of the human brain. In this chapter, you'll learn how to set up the app's memory, how to store information in it, and how to retrieve information at a later time. All right. An app's memory, as it says, consists of a set of named memory slots. It's kind of like a bunch of mailboxes. All right. Some of these memory slots are created as you drag components into your app. These slots are called properties. As it says, you can also define your own named memory slots, which are variables. And again, I've defined a variable as a named memory location whose value may change while the program's running. Didn't notice I didn't say will change, I said may change. All right. Properties. The user of an app, as it says here, can see visible components such as buttons, text boxes, etc. But remember, some of those you also will not see. We've talked about these before. You know, things like the TinyWebDB component, etc. All right. Internally, each component is defined by a set of properties. Those are the values in the memory slots of each property, and they determine how the component will appear on the screen. You've seen this before as I've done things like change the size of text, or what's in a text box, or a label, or whatever. You set the properties directly in the component designer. Okay, and they show an example right here. You can also set many of these properties inside of code as well. All right, they mention down below the picture that you see on your screen right here, they talk a little bit about the canvas property. And it says the canvas property has numerous properties of different types. The canvas, more than anything else, is an example of a property that pretty much is a collection. The idea behind a canvas is that you want to put things in the canvas, sprites, balls, etc. As mentioned here, when you set a property in the component designer, you're specifying the initial value of the property. Again, that value may change as the program is running. You'll see it on screen, you'll see it in your app, but you will actually not see that if you change a color or something back in the component designer window. All right. Defining variables, again, variables are named memory slots, but they're not associated with a particular component. You define variables as needed, typically to make your life a little bit easier. Whereas, as it says here, whereas properties are created automatically when you drag a component into the designer, you must explicitly define properties in the blocks editor. It's the old idea of implicit versus explicit. Implicit is done for you automatically by the software in response to something that you did. Explicit is something that you must do. As mentioned here, when you define a variable, you instruct the app, all right, to set up a named memory location or memory slot, as they call it, for storing the value. Setting and getting, you may or may not have noticed this, all right? When you set up a variable, you've got a get and you've got a set. A get is also referred to as an accessor. It's giving you information. So if somebody says to me, "What's your name?" and I say, "Jeff Scott," that's a get. They are getting my name. When I was first born and I was in the hospital, the nurse maybe came by and there was a tag on me, when I was in a crib or whatever, and they said that maybe the nurse came by and said, "What are you going to name him?" And my parents said Jeffrey Paul Scott, so she wrote that on the tag. Well, the idea is that's a set. So a get is referred to as an accessor. You can't change the value. You are accessing the value. It's like read-only. A set is called a mutator. You are actually setting a value. And if you notice, when we created our variables, and I'll just grab this one and well, it's got both. Notice get set, get set, get set, and get set. All right? When we work at different things in here, so for instance, if I come down to my result label.txt, and I'm not going to grab it to put any of this out there, but notice the actual text itself, there is both a set and this is a get. Now when you're working in here and you're working with the stuff in here that are non-variables, the word get isn't there, but it is a get. You are getting the text, you are setting the text. And you'll notice there are different properties here that you can set: height, width, visible, etc. Setting a variable to an expression. I shouldn't say most, but a lot of the times when you set a variable, what you're going to be doing is you're going to be setting the variable to some predefined value, such as a Boolean variable might be set to false. Boolean is true-false type of variable. A string might be set to the empty string. A number might be set to 0. But it doesn't have to be. You can set variables to the values of expressions as well. Incrementing a variable, well, we've seen this. In other languages, you're able to do things like plus plus to add 1 to a variable. I don't believe that exists in this language here. This is starting to get into a complex expression. This is a simple expression. Set this to this. Now it's set this to this plus this. So we're adding more functionality and we're making it a more complex expression. You can build expressions of any complexity. In other words, of as much complexity as you need to solve a problem. We've learned in the past how to display variables. When you modify a component property, the user interface is affected directly. All right. Now, when you change the value of a variable, it may or may not have a direct effect on the app's appearance. Normally it does not. Sometimes you don't want to immediately show a change based on something. That's an advantage of using variables. All right. And we have not gone through them, but every variable that we've created, so for instance, all these variables here, they're known as being global variables because they're global to the app. If I write a routine though, and in that routine I create a variable, then that variable is known as being local. So it's only available inside of that particular block of code. If a variable is only needed in one place, as it says underneath the figure here, it's a good idea to define it as local. Then you don't get what are called side effects, which are things that happen that you don't necessarily want to have happen. So remember, in summary, when the app is launched, it begins executing, doing whatever it is it's supposed to do. When it responds to events, the app sometimes needs to remember things. All right? One way that you can get it to remember things is by using variables. That's pretty much it for Chapter 16. When we come back, we'll go into Chapter 17, which is a little bit more on animation. And I'll be back with that shortly.